Now next topic is definite integral as the limit of a sum. Let us understand definite integral. Say, suppose that here this line is x-axis, this line is y-axis, and there is a function. This is a graph of a function. It is continuous on closed interval a to b. This function is continuous on closed interval a to b. F is continuous on closed interval a to b. Now, area bounded by this curve between these two vertical line and this x-axis, this is the area. So this area which is bounded by curve between two vertical lines x equal to a and x equal to b, see, bounded by this line x equal to b, this line x equal to a, curve y equal to fx, this is y equal to fx, and x-axis, this can be calculated. Because this is not a regular shape, there is a method to calculate this area, and this area is value of a definite integral of fx over closed interval a to b, and it is denoted as definite integral of fx. So what we do, we integrate fx with respect to x. Closed interval EB, A is lower limit, B is upper limit. Lower value keep at lower end, upper value keep at upper end. This is lower limit, this is upper limit. This is the definite integral of fx on closed interval AB. It calculates this area. Now there is a method to calculate area. What we do, we divide this into strips. This whole area is divided into strips, and we will take sum of area of all these strips. Sum of areas of all these strips, it is equal to area of this region. And method is, we divide this closed interval AB into sub-intervals of equal length. I am enlarging this part here. See, enlarging this number, suppose A, this number I am putting here B, and say here this is first part, this is second part, this is third part, this is fourth part, and this is nth part. First part, second part, third part, fourth part, nth part. So interval, length of interval is divided into n equal parts of congruent length. So closed interval EB is divided into n sub intervals of equal length. Suppose length of each sub interval is h, this length is h. So length of sub interval is h. So h can be calculated. So h equal to b minus a upon n. B minus a divided by n. There are n partitions. Length of each partition is h. So h equal to b minus a divided by n. Now this number of strips can be increased as n tends to, if this as you increase this number of strips, here at present 1 2 3 4 5 6 7 8 9 10, so length of each subinterval is b minus a upon 10. If you divide into 100 strips, then you have to divide here 100 partitions, so strips will be thin, so width of every strip will be decreased. So as you increase number of subintervals, h will be decreased. So we are going to take n up to infinity. We are going to divide this interval into n subintervals. So here we are going to create infinite many strips. So length of each subinterval will be so small as n tends to infinity, h tends to 0. So we can imagine that every strip will be converted into rectangles. As you decrease this length, this curve will be decreased, this shape will be decreased. As you decrease this length of subinterval, this will be thinner and thinner. So this line is going to convert into, as this is going to be 0, this strip will be very very thin, and here this curve is going to be parallel to this line, so this will be rectangle. So here length, this width of rectangle will be h, and here see this is a plus h, this number is a plus h, this number is a plus 2h, this number is a plus 3h. In general, suppose this number is a plus ih, I is 1 2 3 up to I. For this number, b will be a plus nh, a plus 1h, a plus 2h, a plus 3h, a plus 4h, 4 partitions, a plus 5h, 5 partitions, a plus nh, so n partitions. So value of I varies from 1 2 3 4 up to n. So suppose this number is a plus ih, so corresponding y coordinate of this point will be f of a plus ih. So we can imagine that length of height of this rectangle will be, see this height will be f of a plus ih, this will be f of a plus ih, and width will be h. So area of this rectangle will be h into f of a plus ih, h into f of a plus ih. So area of strip, it is h into f of a plus ih. So area of first strip is h into f of a plus 1h. Area of second strip will be h into f of a plus 2h. Area of third strip will be f of h into f of a plus 3h. Like that we can get area of region. This region we denote as, suppose this point is A, this point is B, this point is M, this point is N. So area of this region ABMN is equal to h into f of a plus 1h, h into f of a plus 2h, h into f of a plus 3h up to f of a plus nh. So width into height, width into height, width into height. But here there are infinite many strips. If you take number of strips infinite, then this can be taken as a rectangle. Every strip can be taken as rectangle. So here as n tends to infinity, h tends to 0. So this sum can be written as h into sigma f of a plus ih, I equal to 1 to n. Now here we want h tends to 0. So area of region here as n tends to infinity, h tends to 0. So area is equal to limit h tends to 0, h into sigma f of a plus ih, I equal to 1 to n. So this is formula to find area, means value of definite integral a to b fx dx. It is equal to limit h tends to 0 sigma f of a plus h into sigma f of a plus ih, I equal to 1 to n. So this is the method to find value of a definite integral as a limit of sum. This is sum. So limit of sum, it is area of this region. So this is the meaning of a definite integral. Definite integral, it is area of region bounded by curve y equal to fx, vertical lines x equal to a, x equal to b, and x axis. And to find this area here, this is the method. So doing examples, we will apply this formula. Now see, whatever I explained, formula I have written here in short, and these are formulas for sigma. These formulas will be also used, and you learned this formula in class 11. So say method is, we want 2 to 3x square dx, a to b fx dx. So here a is 2, a is 2, b is 3, a is 2, b is 3. Length of each subinterval h, h is, so h equal to b minus a upon n. So h is 1 upon n, h is b minus a upon n. Then from this equation get value of nh. So nh is 1, nh is 1, therefore nh is 1. This will be used in calculation. See, as n tends to infinity, h tends to 0. N tends to infinity, h is going near and near towards 0, but every time product of n and h is constant, that is 1. Then we find f of a plus ih. So f of a plus ih, f of a plus ih, that is f of 2 plus ih. Now here fx is, here fx is x square. In this question we are taking fx 2x. So fx is x square. Let me take this statement here. A is 2, b is 3 and fx is x square. So now it's okay. Now f of a plus ih, f of a plus ih, that is f of a is 2 plus ih. So putting here 2 plus ih, so we have to put here 2 plus ih. So it is 2 plus ih whole square. So this is 4 plus 4 ih plus I square h square. This is f of a plus ih. So that is found. Now formula. So formula is therefore integral of a to b fx dx equal to 2 to 3 fx dx equal to limit h tends to 0. Let me keep your formula. A to b fx dx equal to limit h tends to 0 h sigma f of a plus ih I equal to 1 to n. This formula. Now putting values in formula. So therefore putting these values in formula, a to b, that is 2 to 3, fx is x square dx, it is equal to limit h tends to 0, h into sigma I equal to 1 to n f of a plus ih. F of a plus ih is 4 plus 4 ih plus I square h square. 4 plus 4 ih plus I square h square. So values are taken in this formula. A to b fx dx, limit h tends to 0, h into sigma f of a plus ih. Now calculating here using this formulas for sigma, say limit h tends to 0. Now what we do here, we are for this sigma I is variable. I is variable for sigma, so we are not allowed to take I from outside sigma. For sigma h is variable. For sigma h is constant. Constants can be taken out. There are two variables. For a limit h is variable, for sigma I is variable. For sigma h is constant and constants are allowed to take out of sigma. From out of sigma I cannot be taken out. So here what we do, h keep as it is, multiplying h with this sigma 4, so 4 taking out, so 4h into sigma 1, 4 taken out, so here 1 is left, plus 4h I am taking out, 4h into h, so 4h square sigma I. Then I am taking h square outside, so h square into h is h cube sigma I square, I equal to 1 to n. So with sigma you keep only I square, I cube or 1, h or constants take outside, and now we use this formula. So it is equal to limit h tends to 0, use here bracket because separated, 4h into sigma 1 is n, so n plus 4h square into sigma I is n by 2 into n plus 1, n by 2 into n plus 1, plus h cube into sigma I square is n by 6 n plus 1 2n plus 1. So it is equal to, now look, h tends to 0. Here h and n both are variable. As h tends to 0, n tends to infinity, but nh is constant. So wherever we find a product nh, we will keep 1. So what we do here, say this is nh plus 4 by 2 is 2. Here we make pair of nh. So there are 2h here, h square, and 2 factors of n. So because we are having 2h, h into h, 1 we join with these factors. So 1h I am joining with this first n, and second h I am multiplying in this bracket. Separation of h. These are 3h, h into h into h, and 3 factors of n. So in these 3 factors, 3h give 1 h, h, h. So multiplying 1h with this n, nh, then nh plus h into 2nh plus h. So it is like a distribution of h cube. So h into h into h. So one h is connected with n, second h is connected in n plus 1, third h is multiplied in third bracket. Close here bracket. Now wherever we find h alone, we keep 0. H alone means 0, but nh equal to 1. nh is 1. So here I keep nh equal to 1. nh is 1. nh is 1. h is alone. So wherever you find only h alone, so keep 0. h tends to 0. Plus 1 by 6 into nh is 1. nh is 1, but h means 0. Only h, that is 0, into 2 into 1 is 2 plus 0. So that is 4 plus 2 plus 1 by 6. This is 1 by 6 into 2, that is 1 by 3. So that is 4 plus 2 6 plus 1 by 3. So 19 by 3. It is required definite integral. Now see, again applying this formula here. A is minus 1. B is 1, that is upper limit. Fx is e raised to x. So a, b, fx. Now h is b minus a by n. H is b minus a upon n. So 1 b minus a upon n, that is 1 minus 1 upon n. So it is 2 by n. H is 2 by n, therefore nh is 2. See, h is 2 by n. As n tends to infinity, h tends to 0, but product nh is 2. This will be used in calculation. Then we find f of a plus ih, and f of a plus ih, a is minus 1 plus ih, a is minus 1. Now f of minus 1 plus ih. So putting here minus 1 plus ih, minus 1 plus ih, so e raised to minus 1 plus ih. Now whenever you have such exponential function, what we do, this constant component we are separating. So it is e raised to minus 1 into e raised to IH. So this can be written as 1 upon e into e raised to IH. So this is f of a plus IH. Now formula. Now a to b fx dx is limit h tends to 0 h into sigma f of a plus IH I equal to 1 to n. Putting values minus 1 to 1 e raised to x dx equal to limit h tends to 0 h into sigma I equal to 1 to n f of a plus IH, that is 1 by e into e raised to IH. Now here this is series, this will be a series of exponential terms. So to calculate this, limit h tends to 0 h into 1 by e I am taking outside. Whatever is constant I take outside. 1 by e is constant. For a sigma I is variable, we can't take any term having I outside the sigma. Now I is 1 to n. So limit h tends to 0 h into 1 upon e. Now see here, putting I equal to 1, so it is e raised to h. Put I equal to 2, so e raised to 2h. Put I equal to 3, e raised to 3h. Put I equal to n, last value is n, e raised to nh. So sum of n terms 1 to n, 1h, 2h, 3h, 4h up to nh. Now look, this is a geometric progression and we have formula to find sum of geometric progression. Formula is already you learned in 11th class. See, a plus ar square up to n terms. Sum of n geometric terms is a into r raised to n minus 1 upon r minus 1. So using here this formula, see, first term is e raised to h. Comparing with that formula, first term is e raised to h. Then what is common ratio? Every number is multiplied by e raised to h. So common ratio is also e raised to h. In this sum, first term a is e raised to h, ratio is also e raised to h, and this is sum of n terms. So using this formula, limit h tends to 0 h into 1 by e. Now applying formula, a into r raised to n minus 1. What is r? R is e raised to h. So say a, this is a into r raised to n minus 1 upon r minus 1. Now in the next step, in every this type of questions, always shift h in denominator. Always do this. So 1 by e into e raised to h, e raised to nh minus 1 upon e raised to h minus 1 upon h. This h is taken denominator of denominator. Now see, it is equal to, now applying limit. Now in this type of questions, we use one more result. limit of e raised to h minus 1 upon h tends to 0, it is always 1. Limit of e raised to h minus 1 upon h tends to 0 is 1. So limit of this term is 1 because h tends to 0. So applying limit 1 by e into, wherever you find h alone, keep 0. Wherever you find nh, keep 2. So e square minus 1 upon, and this is by this result 1. So it is equal to e square minus 1 upon e. So this is required integral 1 upon e minus 1 upon e. Now say this question, here a is 0, b is 4 and fx is x plus e raised to 2x. Length of subinterval h is b minus a upon n. So 4 minus 0 upon n, therefore nh is 4. See, h is 4 by n, so nh is 4. Get value of nh. Always nh will be constant. So now f of a plus ih required to put in formula. F of a plus ih is 0 plus ih, putting a equal to 0. So it is f of ih, and f of ih, putting here ih, f of ih is ih plus e raised to 2ih, ih plus e raised to 2ih. So this is f of a plus ih. Now coming on formula, a to b fx dx is limit h tends to 0 h into sigma f of a plus ih I equal to 1 to n. So it is equal to limit, now putting values, therefore 0 to 4 fx dx, that is x plus 2 e raised to 2x dx. This is fx dx equal to, it is equal to limit h tends to 0 h into sigma I equal to 1 to n f of a plus ih. So this is f of a plus ih plus e raised to 2ih. Now here we are getting two groups, sigma I group, and next is a geometric progression. So say here, separating there, limit h tends to 0 h into sigma ih, h is constant for sigma, so take out, so h square sigma I equal to 1 to n plus h into sigma e raised to 2ih. Separation of sigma I equal to 1 to n. Always keep remember, for sigma h is variable, h is constant, so h always we take outside, so h into h square. For sigma I is variable, we are not allowed to take I outside. Now limit h tends to 0 h square into sigma I 1 to n is n by 2 into n plus 1. Here see sigma when works, it gives, putting I equal to 1, e raised to 2h, put I equal to 2, so e raised to 4h, put I equal to 3, so e raised to 6h, up to putting I equal to n, e raised to 2nh. So this is geometric progression, and here we shall use that formula. So it is equal to limit h tends to 0, here make pair of nh, there are 2h and 2 factors of n, so 11h we set with this 11n, so nh 1h keep with n, 1h join in this factor, so nh plus h by 2 plus h into, now applying this formula, here first term is e raised to 2h and common ratio is also e raised to 2h, so putting this formula, e raised to 2h, that is value of a, into r raised to n minus 1, r is also e raised to 2h upon r minus 1, that is limit h tends to 0. Now see here giving a limit to this number, wherever we find nh, first of all what we do, separation of limit, limit h tends to 0, nh by 2, nh plus h, plus limit h tends to 0, limit of this number. Now here what we do, h we take down, so here e raised to 2h minus 1 upon h, this h comes in the denominator, here e raised to 2h, here e raised to 2nh minus 1, this is h, here nh. Now see, to apply this formula, whatever number is here, same number must be here. If here h is given, here h must required. If here 2h is given, here 2h must be there in denominator. If here 3h is given, whatever is here, same number should be here. So here because 2h, so we need here 2h. So multiply by 2, divide by 2. Multiply and divide by 2. So now here this is the pattern of this formula, e is to 2h minus 1 upon 2h, and 2h tends to 0 because h tends to 0. So this will be 1. So now putting limit, it is equal to nh is 4, so 4 by 2, 4 plus, wherever you find h alone, keep 0, plus e raised to 2h, h is 0, h was alone, into e raised to 4 into 2, 8, upon 2 into 1, this will be 1. So it is equal to, this is 8 plus e raised to 0 is 1, e raised to 8 minus 1 upon 2. So it is equal to, 8 into 2 16, 16 minus 1 15. So e raised to 8 plus 15 by 2.